My name is Jeff Brecht, and I'm a post-harvest physiologist at the University of Florida, where I have research, teaching, and extension responsibilities, primarily related to the distribution system for fresh fruits and vegetables. And I'm going to be talking today about transportation and distribution issues, specifically for fresh cut produce. Before I get completely into this presentation, I wanted to point out that we recently released a publication which is a revision of a USDA Ag Marketing Service Handbook that was last revised in 1995. It was just released now in April 2019, Protecting Perishable Foods During Transport by Truck and Rail, which was written by myself along with my colleague at UF, Steve Sargent, my brother Patrick Brecht, who has worked for many years in the transportation industry with perishables, Jorge Sainz, and Leonard or Bud Rodowick, who both have a lot of experience with Thermo King related to transportation refrigeration. And that's available at the UF EDIS website for extension publications. So this slide is showing refrigerated trucks with trailers backed up to the loading dock of a distribution center. And I have that picture just to remind me of the concept that the time that fruits and vegetables spend in transportation is akin to storage. A lot of these products, and especially fresh cuts, are not stored to any extent. So the time that they spend within the distribution system in trucks or other modes of transportation really can be a very significant part of their post-harvest life. And so we need to pay attention to things like temperature management in order to be sure that we have the maximum quality of these products when they finally reach the consumer. And the guiding concept here is quality in, quality out. You have to start with good quality product, of course, but also it has to be handled properly. So the idea of the cold chain, having the products properly pre-cooled and the transportation equipment also pre-cooled before loading so that you always have the products at a cold temperature, no chance for them to warm up en route or at any time during the handling, and that's how you're going to maximize the safety, the quality, and the shelf life of the product after transport. So you know very well already by this point that temperature is the very most important factor determining the quality of fresh fruits and vegetables. And for fresh cut products, it's even more critical because of their highly perishable nature. So for effects of temperature on horticultural commodities, of course, all products are harmed by exposure to excessively high temperatures and also low temperatures. Fresh cut products should ideally be transported at 32 to 38 degrees Fahrenheit, which is 0 to 3 centigrade. And this is basically saying that they should ideally be transported at the lowest safe temperature that doesn't run the risk of freezing the product. And that's determined within that range by the capabilities of the transportation refrigeration equipment that you have, because the temperatures are going to fluctuate above and below the set point, and you don't want them to be able to fluctuate down into the freezing range for the product. Tropical and subtropical fresh cut products, yes, the products are chilling sensitive, but they still need to be handled at that same low 0 to 3 degree centigrade temperature range, unlike the whole products. And the reason is because when the fresh cut products are processed, they become so much more perishable that trying to put them at a safe, non-chilling temperature would shorten their shelf life so drastically that they could never be sent through the distribution system successfully. So you're better off putting them at the low temperature to reduce the deterioration and treat them as if chilling injury is not even a concern. So the idea, as I mentioned already, is to maintain the cold chain. You want to make sure that at every step from beginning to end through this process, from right after harvest all the way to display in the retail store when the consumer purchases the product, that the fresh cut products are always in that low temperature range in order to maintain their quality and in order to realize long enough shelf life for them to be saleable. Can start with loading and unloading on refrigerated docks in the transportation phase. So you have closed doors where the trucks back up to, and where the product is accumulated coming from the cold storage is also a refrigerated loading dock. When each door is opened, the truck has already backed up against um, uh, a gasket, so to speak, so that it's sealed, and then you have a continuous environment, cold environment, from the loading dock to the interior of the truck, which should have been already pre-cooled before it's opened for loading. Transportation equipment in general, I'll give some description about that so you have a better understanding of how it works and the considerations that you need to take into account. So there's two main types of containers that you may see on the road. Primarily, those are refrigerated trailers attached to trucks. You also have marine containers that are carried on ocean-going vessels, but once they get unloaded at the port, they're also put onto a flatbed type of um, system on a truck, and then they also go over the road. So products can be in both of those. Fresh cut products primarily are going to be in truck trailers, though. And those two types of systems have completely different air delivery systems for that refrigerated air. There's top air in the truck trailers and bottom air delivery in the marine containers. And it's important to understand that in both cases, this refrigerated transport equipment is designed to maintain temperatures. So you can't put warm product into a trailer or a marine container and expect the refrigeration equipment to have enough capacity to cool the product. It has to already be cold when it's put into the trailer or the container. Air transport containers, on the other hand, usually have no refrigeration unit. They may use dry ice or what's known as eutectic mixtures, which are mixtures that freeze at lower temperature than either component. Um, and they have minimal air circulation as well. So air transport relies just on being fast with minimal temperature management, and it's really not something that is recommended for fresh cut products. So the top air delivery system, um, it's interesting to note that this was a system that was originally designed for frozen products. And the idea was that you would load the cargo in a solid block in the center of the trailer with air space all around it on all sides. And then that refrigerated air would circulate around the outside of the cargo like a cold air envelope that would insulate the frozen cargo from the outside environment and prevent any chance that it could melt. So that was then adopted for fresh produce, and there's a huge difference between frozen and fresh in that the fresh products are respiring and therefore they're generating heat. So this modification doesn't really work as well as it could because it's difficult for the air to get into the interior of the cargo load. So that's why fresh cut produce needs to be pre-cooled very well because you don't want the center heating up significantly, which is what will happen if it's already warmer than the set point temperature when it goes on to the trailer. The bottom air system was specifically designed for the longer transport distances that you have in international marine transport. And it's a completely opposite system in that the air, instead of being delivered along a chute from the top of the space, is actually delivered underneath the load through spaces in the floor. And the load is not put in there with spaces around the outside. It actually is intended for the entire 100% of the floor to be covered with the cartons. And the reason is for that is so that the air being delivered in the bottom of the container can only go up through the packages, the cartons, to reach the top and return to the refrigeration equipment. So you have much better contact between the cold refrigerated air and the products in a bottom air delivery system. So transportation doesn't have to be a black box. It's not like you load your product into the trailer, shut the doors, and it takes off and you have no control over what is going to happen. First of all, there's temperature recorders. Usually that's something that is required, and the temperature recorder is usually placed near the rear of the trailer, and the intent is for it to measure the discharge air temperature that's coming out of that air delivery chute. It provides documentation of the refrigeration or reefer unit performance. So if something goes wrong and the reefer unit stops working, the temperature recorder is going to give you a record of that. It's possible that you can have probes to record product temperatures also, but that's very, very rare. The only time I've ever really seen it done is in international shipments where there is a cold treatment being used for insect quarantine. But I've actually never seen that being used for domestic transport. It is really important that you calibrate the temperature sensors so that you know that they're reading accurate temperatures so that the record that you get is something that you can rely on. Maintaining temperature uniformity during distribution. Because the products are respiring and generating their own heat, there's the possibility that you're going to get hot spots developing within a load if there are parts of the load that aren't coming in contact with that refrigerated air in order to remove that heat. So it's possible to do some temperature mapping during shipping, not routinely necessarily, but as a investigation or a diagnostic type of exercise. You can determine if there's temperature non-uniformity developing due to equipment limitations, due to the way the product is being stowed in the trailers or containers. And like I said, it's possible for hot spots to develop within a load. And if you put product into a trailer or a container that's not completely pre-cooled, then that magnifies the temperature differences that may occur during transport. So you can use temperature mapping to diagnose temperature problems, for example, improper stowage, and then take actions to improve the situation from that point on. These are some records of some temperature mapping studies that we did with, actually these were strawberries, not a fresh cut product, and these are from truck shipments from California to Florida, about a 4-day transport period. And the temperature range here is 0 to 10 C, which is 32 to 50 Fahrenheit. And you can see that all of these are starting off at around 1 degree, which is 34 degrees Fahrenheit. That's great for strawberries, but they're all actually increasing slightly in temperature, or in some cases more than just slightly in temperature during transit, because strawberries have a very high respiration rate and it's very difficult to maintain that temperature. The three figures on the right that show greater temperature increase, those are actually shipments using the Tektral pallet cover, the plastic bag that goes over a pallet of strawberries and is sealed so that you get a modified atmosphere at the pallet level. So that actually inhibits the removal of heat from the strawberries, and you can see that it has a greater effect on the temperature rise that can occur. And so I use this example. I don't have an example for fresh cut products, but many, if not most, fresh cut products are in modified atmosphere packaging. So there's also that potential that they could be increasing in temperature during transport because of the packaging itself inhibiting the direct contact between the refrigerated air and the products. So we did some research in this regard to determine what's the best way to see what's happening in terms of the temperature zones within um, a container or a trailer. And so a PhD student, Cecilia Amador, did this work. She put in upwards of 50 temperature recorders in each load of produce, measuring the temperatures throughout, and came up with 3 areas where, at a minimum, you can determine what's going on in the load. The first is inside one of the first pallets near the front bulkhead, so that would be position 1 or 2. And that would detect any occurrence of short cycling of the refrigerated air, meaning that it comes out and then goes right back to the refrigeration unit instead of circulating through the whole load. The second spot would be inside one of the pallets near the center of the load, and that's where the product heating is most likely to occur. That center part of the load, that's where the heat of respiration tends to have the greatest effect. And then the third spot is near the back. This is where when people put a temperature recorder in a shipment now, it's usually stuck onto one of the rear pallets. So that tells you the air temperature being delivered. As I said before, it's the air temperature at the farthest point from the reefer unit. An important note, though, is that the recorder should be placed on or in one of the pallets, not on the wall of the container, because if you put a temperature recorder on the wall, you may get elevated readings from the outside environmental temperatures, and those readings don't accurately reflect the air temperature in the load space. Another note that I should make is that these temperature recorders are measuring the air temperature, so the closer you can get them to the product itself, the better representation you're going to get of the product temperature. So in doing this kind of an exercise, if you're doing it for diagnostic reasons, it's better to put these recorders right in the cartons with the product rather than outside the pallets. What's available now actually are reusable, disposable temperature relative humidity sensors with tracking. So it's easier than ever to do this kind of temperature mapping. You can have RFID or cellular enabled data loggers, so you can have real-time monitoring of conditions. We just this past summer actually did a number of test shipments using these kind of data loggers that connect whenever a cell phone tower comes in range. They connect and upload the data, and so you can see what's going on in real time. And in a commercial setting, this could allow you to take some corrective action if you see that something's going wrong with a load en route. They also have GPS tracking that allows you to follow the geographic progress of the shipment. You can get email alerts in some systems so that when a predetermined temperature or humidity threshold is breached, you get a warning of that. So for example, I'll talk more about this later, you may have a critical temperature that above which if your product is exposed to that temperature, it would be considered adulterated and unsaleable. You can set a temperature somewhat below that, so you get a warning that the temperature is creeping up, and you get that warning before it reaches the critical temperature. And these can be associated with shelf life models as well, which can be used to help determine the logistics of distribution of the products, something that we've done research on as well. So this is some work by my colleague Ismail Usal. He was a postdoc at University of Florida. Now he's a professor at University of South Florida in Tampa. And this is looking at the relationship between the measured air temperature and the actual product temperature. So the product temperature always lags behind the air temperature changes. If the temperature fluctuates, quite often the product temperature barely changes, even when the air temperature seems to be fluctuating quite wildly. The reason for that is that the 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 air is not a very good transporter of heat, so the temperature changes quite rapidly. Whereas the products have a large water content, and so they have a lot of heat capacity, and they don't change temperature as easily. So this is some illustrating some work that Ismail did to determine what's the relationship between measured air temperatures and actual product temperatures, which we then applied to shelf life modeling so that when determining the effect of temperature on the shelf life and quality of products, we were actually doing that based on the product temperature, even though we could only measure the air temperature in most cases. So transportation solutions. Um, my brother, who I mentioned before as one of the authors of the revised transportation handbook, is someone who's worked in the transportation industry most of his career. He's actually a consultant now doing what he calls forensic studies. So what that means is he's the person called in when there's a dispute over the condition of a load that's arrived somewhere, and he tries to determine what happened. And so Pat says that human error accounts for up to 80% of cargo losses during transportation. And in the international shipping arena, one of the biggest errors that he sees is the simple um, uh, confusion between degrees Fahrenheit and degrees centigrade settings. So, for example, if something is supposed to be transported at 34 degrees Fahrenheit and someone sets it to 34 degrees centigrade, that's 90 degrees Fahrenheit. So you could see that's a disaster. And on the other hand, if something is specified, say, at should be shipped at 5 degrees C and it gets set at 5 degrees Fahrenheit, well, that's 27 degrees below the freezing point of water. So what that means is that we need to take advantage of the modern capabilities of the refrigeration equipment. The microprocessors that are associated with the reefers allow you to markedly reduce human error, driver decision making, driver intervention. Some of these are set so that they're set for a particular product and all the settings are predetermined, and the driver can't change them, for example. So you could be measuring and controlling both the discharge and return air from and to the refrigeration unit. You can set upper and lower set point limits, as I mentioned before. You can control fan speed to reduce energy usage. There's a lot of things you can do, and both um, Carrier and Thermo King, the two major manufacturers of transportation refrigeration equipment, have these kind of capabilities in their units. And also the microprocessor documents refrigeration unit performance. And that's actually something that's important in terms of record keeping, to keep records of the performance of the equipment so that you can show that you are using properly performing equipment to ship your product. Another very critical point in terms of transportation solutions is proper stowage. Improper stowage is a leading cause of poor temperature management and cargo losses. I mentioned before when I was describing how top air and bottom air systems work, that it's really critical how you load the product into those two types of units. It's really important. I mentioned that with frozen cargo, the top air delivery was designed so that you would have cold air on all six sides of the load. But it's also very important that you never let the pallets touch the walls of the trailer, because you can have heat or cold outside temperatures that are going to affect the product that's touching that wall. And so you can have quality problems related to that. Also, you need to have enough airflow going through the load of fresh produce so that you're not allowing it to excessively heat up during transportation. And so you have to take advantage of the venting in cartons or the spacing between cartons so that air can move through the load to the greatest extent possible. So reefer microprocessors actually can sense and record things like short cycling of improperly loaded trailers, and that can have immediate application by protecting carriers from elevated cargo temperature and related food quality and safety concerns, because that short cycling will show up quite quickly and you can do something about it before the whole load is compromised. There's also expert systems. So I mentioned before that you may be able to just press a button and have a setting for a particular product. And so, like I said, the refrigeration equipment companies have that possibility. So they will take into account the temperature sensitivity of the product, of course, what the optimum temperature is. They can change some settings to reduce energy consumption versus erring on the side of maintaining the most precise temperatures possible, which of course would be the settings that would be used for fresh cut products. And that takes a lot of the decision making out of the hands of the operators, because experts have determined what the best settings are for each individual product. You also have data loggers and telematics. So there's record keeping, traceability, and verification issues related to equipment performance, and these microprocessors keep track of all that. So you're keeping track of performance of the equipment, the pre-trip checking of the equipment, that it's all in working order. You can tell whether the product was pre-cooled or not before it was loaded, whether the stowage was proper, and then you have records of time and temperature in transit. You have records related to security, like was the back door opened or not during the shipment. So the pre-trip is the jargon used for checking the performance of the refrigeration equipment before each trip, and that's a critical control point in quality control for transporting fresh produce. Properly pre-tripping the reefer equipment is really key to preventing loss of quality issues, because if you send something off and something's not working correctly in the reefer unit, then you're obviously going to have a problem en route. So pre-tripping the reefer unit, which is really the central nervous system of the reefer trailer, is something that can be easily accomplished and recorded almost any time. It's a very easy thing to do. You just have to follow the manufacturer directions. So upper and lower thermostat set point limits as a critical control point. So this is something I mentioned once before. Setting and locking upper temperature limits are critical for control of food spoilage. The time temperature critical limit is the point that, if exceeded, the quality of the food may be compromised. So currently, for example, fresh cut leafy greens, fresh cut melons, fresh cut tomatoes. Actually, it's specified by FDA that if those products exceed 41 degrees Fahrenheit or 5 degrees C, they'll be considered adulterated, which is a legal term that is equivalent to saying that something has been poisoned. And so it becomes a legal issue that that product can no longer be sold. It has to be discarded. So it's very important that have you have steps in place so that you can catch the product before it reaches that temperature limit. So if you're sending something at 34 degrees and 41 degrees is that critical temperature limit, you might want to set a warning to go off at, say, 37, 38 degrees so that you know that the temperature is rising and you can try and take steps to keep it from reaching 41 degrees. So what that means is in practice, the operating limit, which is that mid temperature, would be more restrictive than the critical limit, which is the uppermost temperature above which the product becomes unsaleable. So if the operating limit is triggered, the carrier can step in and take some kind of corrective action to fix the problem before it becomes critical. Now on to shelf life issues. There's many possible algorithms for shelf life estimation. For example, the Arrhenius equation, which is used in biochemistry to describe the activity of enzymes. And so a typical shelf life plot for a food product would be this kind of change in quality over time as a function of temperature. But produce is really more complicated than that. This really only works if there's a single reaction or if the growth of a single microorganism is what determines the shelf life of the product. And what we found is that different quality factors actually limit shelf life at different temperatures, and it's specific for the type of product. So to do this kind of shelf life description, you have to start with knowing the initial quality, and then you have to know what the shelf life limiting quality factors are at different temperatures for the product. And then what you can do is you can determine the residual shelf life at any point in time and predict what will happen going forward under different predefined conditions. And so what the model does is it predicts the final quality index and the residual shelf life. So as an example, this is work that another colleague, Cecilia Nunez, and her husband, Jean-Pierre Imond, have worked on quite a bit for 40 or 50 different products. This is showing for spinach the changes in quality for different quality factors, including the taste, the aroma, the color, the shriveling from water loss, the appearance of injury symptoms. And you can see that what this is showing is a rating of 3 is the limit of salability, that at different temperatures you have different quality factors determining what's going to limit the shelf life. The tag accuracy also varies with temperature. So this is back to Ismail, some of the things he's done. So you have to choose a data logger that has its best accuracy in the temperature range that you're interested in. And he calls that context-based accuracy. So we've also used that in the shelf life modeling to improve the accuracy of the shelf life estimation. And here's some results from strawberry validation tests, tracking the temperature, measuring the quality initially, and then tracking the temperature during distribution and predicting at what point the strawberries are going to reach their limit of salability. And what we found is at the distribution center, if we had to make a decision at that point, the worst case out of 6 tests that we ran was that there would be a 9.5-hour difference between the predicted and observed shelf life over a 7-day period, or out of a 7-day distribution system scenario. If the same thing was done at the retail store, we came within a few hours again. The worst was an 8-hour difference, again, over a 7-day shelf life, predicting when the strawberries would reach the end of their shelf life. So what this allows you to do is potentially at the distribution center, you can decide where different loads of product can be shipped and when. Which should go out first, which should go to the nearest stores versus the farthest stores, and that sort of thing. And that's called first expired, first out decision making, as opposed to first in, first out, which is what's normally used. And we found that using this shelf life modeling and FIFO decision making resulted in about 30% less shrink than using FIFO. Okay, now during the time I have left, I'm going to shift over to more focus on food safety during transportation and distribution. First question, is there potential for raw product cross-contamination from previous loads? This has been a big concern of FDA over the years and something that we looked into with some research in the past. Because if you're shipping different things in the same equipment, meat, fish, dairy, or eggs could leave residue contaminated with human pathogens that could potentially get onto fresh produce. And so there is some chance of that with whole fresh produce. It's not so likely for fresh cuts because they're packaged, but importantly, the packages themselves can become contaminated, cross-contaminated from what was in the trailer in the shipment before. So it's recommended that you sanitize any reusable pallets, bins, etc. Be aware of prior load history and act accordingly. So in other words, if a prior load was some kind of meat product, that's maybe more likely to carry a human pathogen. You probably should do a more strict job of cleaning and sanitizing the trailer than if that's not the case. For food safety organisms, the temperature effect is a little bit complicated. So while low temperature preserves the quality of food, and the FDA rule mandates that fresh cut leafy greens and other fresh cuts have to be maintained at or below 41 degrees to prevent the proliferation of food pathogens. The survival of those pathogens is actually a little bit more complicated. So the fresh cuts should always be in that low temperature range anyway. In reality, the temperature versus food safety is sort of a balancing act. So this is what I'm going to say now is based on research done by Keith Snyder and Michelle Daniluk, two food safety microbiologists at UF. The first is that low temperature slows pathogen growth, so that's fine and good, but ironically it also prolongs the pathogen's survival, especially if there's a food source available. So the survival of these pathogens on fresh cut is actually extended at the low temperature that at the same time is slowing their potential growth. At high temperatures, you can also shorten pathogen survival times if the humidity is low. So the outside environment is actually not very conducive for survival of these pathogens. The worst case scenario, however, is when you have high temperature and high humidity plus a food source. That's where you get proliferation. And that almost exactly describes the situation inside a package with fresh cut produce, because you've got if the temperature goes above the critical point, you've got high humidity, you've got the cut produce, so the interior tissues are exposed and available as a food source for the pathogens, and that's where you're going to get proliferation. So, cleanliness and sanitation. First of all, pre-clean and pre-rinse. You want to have adequate contact time between the water, the sanitizer. It's not enough just to do a quick spray. You sometimes have to leave it there for a certain amount of time in order for it to have its sanitizing effect. You have to choose the proper cleaner for different types of materials. So this is all following label directions basically. I won't go into details here. Then the other option is using mechanical heat disinfection. This is basically describing pressure washing. You can clean with 6 to 8 gallons per minute at 650 to 850 psi, 180 degrees. Rinse with 60 to 80 psi, 180 degree water. This is from USDA recommendations. So that's basically what you can do. Talking with Trevor Suslow, who some of you may know, UC Davis food safety expert, he says that he's found in many cases where this kind of pressure washing is done, it's not done thoroughly enough, and so you have the potential of just spreading the pathogens around rather than actually killing and removing them. So you really have to do this properly for it to be effective. The refrigeration equipment itself is something that is often forgotten in this area of cleaning and sanitizing. All of the air moving through the container goes past the refrigeration coils, and particles can be trapped there. So it's a good idea to have as um, part of the regularly scheduled cleaning program that you open that up, vacuum out the physical material, the dust and the bits and pieces, and it's possible to use gaseous oxidizers, like you can put an ozone generator into a container with the uh, refrigeration unit running, and uh, um, and that will kill the pathogens. I don't recommend using ozone routinely because it's such a strong oxidizer that it actually can have negative effects on the materials that the trailers are made out of. Things like rubber gaskets and plastic and glues can all be oxidized and deteriorate more rapidly if there's constant exposure to ozone. You need to clean the air distribution system. Remove the air delivery chute, remove the return air bulkhead, clean the evaporator outlets and inlets, clean that return air bulkhead before you put all that back together again. Now, government regulations. I'll finish up with this topic. You all know about the Food Safety Modernization Act. And there's a final rule for sanitary transportation for human and animal food, abbreviated FRST, which was released in April 2016. It applies to shippers, loaders, carriers, motor or rail carriers, and receivers, everyone involved in transporting food. Everyone has to document that they're following sanitary practices to ensure the safety of the food. So the goal of this rule is to prevent practices during transportation that create food safety risks. So that includes failure to properly refrigerate the food, so that has to do with the temperature management. Inadequate cleaning of vehicles between loads, failure to properly protect food, that has to do with packaging primarily. There we go. The rule became enforceable in April 2017, so everybody should be following this rule now. The final rule for sanitary transportation requires that hazard evaluation consider transportation practices. So you need to avoid situations like failure to adequately control temperature during transportation. You need to provide adequate protective packaging. You need to avoid inadequately cleaned vehicles. You need to avoid inadequately protected foods that are being co-transported, meaning mixed loads that are potential sources of cross-contamination. Use sanitary transportation practices to ensure that food is not transported under conditions that may render the food adulterated. And that actually includes temperature, as I mentioned before. So the categories include appropriate equipment design and maintenance, clean and sanitary trailers, personnel training, and record keeping. So appropriate equipment design and maintenance. That means that the design, the performance, and the maintenance of the equipment is a fundamental prerequisite. That needs to be done on a regular basis, and you need to keep records. It requires that the shipper provide in writing to the carrier and loader all the necessary sanitary specifications for the carrier's vehicle and transportation equipment. So a big part of this is communication between the different parties that are taking and receiving the shipments. Clean and sanitary trailers. Remove all loose debris and wash or sweep the floors clean. That's step one. Then develop and implement procedures that specify practices for cleaning, sanitizing, and inspecting equipment. How the vehicle or equipment is being used, the production stage of the food being transported, in other words, raw versus finished product, open versus closed containers. So you have to have a procedure in place for how you're going to clean and sanitize and inspect the equipment. Personnel training. So you have to have individual company designed shipper, loader, carrier personnel training that's specific to their part in the transport process. Develop and implement written procedures. Training must provide personnel with an awareness of potential food safety problems that may occur during food transportation and basic sanitary transportation practices to address those potential problems. Personnel training needs to include preloading verification to ensure safe food, shipper, loader, carrier requirements for handling non-fully enclosed foods to ensure safe transport, pre-cooling requirements, temperature transport requirements, and these requirements must be communicated in writing. Training records must be maintained for 12 months beyond the job function. So again, record keeping is very, very important in this. So the point is, if anything actually happens where you may be under suspicion of causing a problem related to food safety, your records are what is going to determine whether you're determined to be at fault or not. And you're going to find, if this ever happens to you, that if one party has good records and the other party has poor records, the blame is probably going to fall on the party with poor record keeping. So you want records of equipment design, performance and maintenance, cleaning and sanitizing, cooling, loading and temperature management, training plans and training sessions. All the agreed requirements must be agreed and communicated in writing between the shipper, the loader, carrier, and receiver. And those records are subject to FDA inspection upon oral or written request. So this all plays into traceback. FDA also requires that you be able to have records saying what was the source of everything that came through your facility and where did it go when it left your facility, who handled the product, what was shipped in terms of lot identification, where did it come from and where did it go, was it stored for any time, when did it depart, and when did it arrive at each facility. Who has handled the product, what was shipped, where did it come from, where did it go, when did it depart, when did it arrive, and then trucker's logs. What was hauled in that equipment previously, where was the truck previously. You have to have those records on hand as well. Claims and recalls. So transporters need to have records to protect themselves, as I already said. temperature records and reefer diagnostic records, equipment maintenance and cleaning records, logistics records demonstrating prompt handling, product temperature and quality records. The burden of proof of a loss shifts to the transporter when the shipper has good records and the transporter has little or none. So, I'm going to finish up now with recommendations. Cool the products rapidly after harvest and maintain the cold chain throughout handling, fresh cut processing, and distribution. Set maximum and minimum acceptable temperatures for transport. Pre-cool the trailer or container before loading as well as the product. Document that all the products are at the proper temperature before loading. Use recording thermometers to monitor product temperature during transport. Maintain records of product temperature and quality and reefer performance. Inspect trailers for odors, dirt, filth, and debris before loading. Check for residues of previous cargoes. For example, if there's blood on the walls from previously carrying some kind of meat product. Have trailers cleaned and sanitized if necessary before loading. Work with the shippers and consignees to maintain integrity of lot identification and traceback systems. Maintain records of prior cargoes and equipment, cleaning, and maintenance. And I'm finished. Thank you for your attention.